Here we go, part 5, analyzing data. This is where digital archaeology, for me, gets really exciting because this is sort of akin to what we talked about with part 3, where we talked about the creation of new data and the dissemination of it. This is actually using the tools of the digital world to give us results that, frankly, we were really stymied and unable to deliver beforehand or really hadn't even thought through. For me, this is treating archaeology as big data, and instead of working with smaller data sets that one person can handle, now I can work with larger data sets that a computer can handle. Let me make that clear to you by showing you examples from my work at Elephantine a week and a half ago, shall I? So let's do it. I'm a ceramicist, and so we're going to be focusing on analyzing data by analyzing one specialist's toolbox. So instead of just looking at the whole excavation, which yields data about the features, about the matrices of the area, as well as all of the different types of finds, I'm going to focus on one type of find, which is worked by one specialist, me working on Egyptian ceramics. This is what my world looked like a week and a half ago at Elephantine. And so you can see here that I have this is one separate, I think that might be two. No, that's one. That's one locus of sherds. So one moment of human deposition. You're looking at stuff that was found on the floor of an ancient Egyptian house. So this theoretically represents for us material that was actually used during the lives of the people in that house, or at least has more likelihood of being used that way. And down here at the bottom, these are the more interesting sherds, if you will. Those are the rims, the handles, the bases, the diagnostic sherds, which I introduced to you already in so many words, I believe last week in our lecture about trade, and it's labeled on your PowerPoint. The sherds up here are body sherds. Those are sherds that come from the middle of the vessel, and it's hard to tell the type of vessel, unlike a rim sherd, where the rim sherd of a mug versus the rim sherd of a bowl, you could sort of tell those apart. Here, it's the middle of the vessel. It's hard to actually tell, did it come from a mug? Did it come from a bowl? Did it come from a plate? Did it come from a vat? Did it come from a cooking pot? All of that's really hard to distinguish. So the stuff I'm looking at is really ugly. And on the individual level, if we have to have a moment of honesty, individual sherds don't yield us tremendous amounts of data. This is about as beautiful as the sherds get. I'm showing you the pretty stuff here. I'm showing you the sexy stuff here. And that's as good as I could do, guys. I really worked for this. So you can see that these are rim sherds. These come from the top of a vessel. This one's, oh, that one's pinched like the sides of a pie crust. Is really quite beautiful. They have incised decorations. Here's wavy incised decorations and lines, another wave and lines. And this is some sort of punctated thing, perhaps a filter, even though it's not punched all the way through. We have 3 little pieces of it, so maybe a colander sort of thing. But on the individual, what does this allow me to say? Well, they use pots with wavy decoration. That doesn't help me so much. What I'm really interested in is aggregate data here, putting all of this together and looking at it large scale. So seeing, do they have a lot of these or few of these? Do they use a lot of coarse, ugly, utilitarian types of pottery? Do they put a lot of really nice pottery into the cooking fire? I want to see general big scale trends, and that requires I look at large amounts of data. That's sort of looking at large amounts of data. That's what digital archaeology is really, really well prepared for. So let's see what we're doing here. I want to bring you to a technology that I'm working with together with a company called InfoArch. This is business intelligence. So they're a business intelligence company where what they look at is essentially large scale big data, aggregate data, and try to elucidate trends so that businesses could actually respond to those trends, preferably in real time. And when I say businesses, I really mean institutions. They do a lot of work with hospitals, and they do work with the World Wildlife Fund. So a lot of good stuff is being done. And you can see that the goals of business intelligence, looking for trends in large amounts of data, really fit with my goals as a ceramicist, looking for trends in large amounts of data and trying to understand the culture. In this case, I'm trying to understand the culture of a town or of a home. Business intelligence is often trying to understand the culture of an institution or the needs of an institution, but it's not terribly different. So this is predicated on needing access to data, right? And so once again, all of that data that I'm collecting via ceramics, which I am collecting on paper forms, needs to be made digital. So stuff that looks like, I know I have an example of this already. There you go. You will actually be seeing this again, but this is what my form looks like in its creation when I'm building it. This form, all born on paper, needs to somehow get input, and I'll give that to you again. If you'd like to see it more, I recommend pausing it now to try to understand. Actually, you know, I'll even step back. So you can see that I'm looking at where, which is, think of it as, like, do I have really ugly pottery? Do I have pottery that has medium sets of skills and finishing involved? Or do I have stuff that's really nice and finely produced? Has it been given a red slip? So has it been treated on the outside to make it nicer, less porous? Is it colored red in, out, or in, out? And how has that been handled in relationship to blackening on the interior and exterior surfaces? I need to get all of these data somehow into this format in order to have it analyzed. So one of the first things that happens is that all of this data gets input online, and you can see this is we're working on it right now. The scientists, the data analysts, the data scientists at InfoArch are working on getting a input that I can do offline, off of the web via iPad, so this can be born digital. That aspect's not fully live yet, but we have been able to, through my research lab and myself, get a tremendous amount of data input into the system so that you can see, so that is all accessible into the online database. Now, the input is very nice and very user-friendly. So if I give you the tag number, I'm just gonna insert something so we have some trial, process by law, and let's go ahead. Interesting, we're gonna have to fix that. Let's go for detail processing. Actually, let's go for elephantine because you're a little more comfortable with that. At elephantine, what you see that we can do here is I'm going to insert the tag number. Nope, we're going to go with Kamal-Hisson, I apologize. So I'm going to insert the tag number. I'm going to have the date. I'm going to say who it's processed by. And then I'm going to say that this is detailed processing, and I'm going to add a record. And what it's going to allow me to do is to add this record to actually put the data in really quite nicely, well organized, low levels of data for a body sherd, higher levels of data for a diagnostic sherd. And once I hit save, it will all go into the database. Database looks like this right now, and so I can edit individual records, but I want to, again, even though this looks, okay, we're going to have to do that. So even though that this gives you a pretty beautiful format, right? Where you can see the count and the weight and all this good material here, and I can go in and I can edit them individually. You'll notice that ultimately I could also go in and export to Excel. And when I do that, I get material like this. So you see that even though I have a glossy front-end database, much of that data can be handled by Excel, though I would not want you to originally enter this via Excel, because what that allows us to do is actually have a higher degree of user error. So once we get this and all of these complex data involved, I promised you that we were going to get to analysis. So how does having this data entered into a database and made digital, how does this enable us to do analysis? Well, this is where the visualizations come in. So this is a trial right now of the material. This is not live. And so